evaluate the definite integral x square into dx from 2 to 3 as the limit of sums. Let's begin with the solution. And we have integral of x square into dx from 2 to 3. Now, by the definition of integrals as the limit of sums, we know that integral of fx into dx from a to b is given by b minus a into limit as n approaches to infinity 1 upon n into f of a plus h plus so on up to f of a plus n minus 1 into h, where h is equal to b minus a upon n, and this tends to 0 as n tends to infinity. So here a is equal to 2, b is equal to 3, so this implies that h is equal to 3 minus 2 upon n, this is equal to 1 upon n. Now let us find f of a. F of a is f of 2 and the function fx here is x square, so this implies that f of 2 is equal to 2 square. Now we have f of a plus h, that is f of 2 plus h. So this is 2 plus h whole square. Then we have f of 2 plus 2h, so this is 2 plus 2h whole square. And finally, let us find f of a plus n minus 1 into h. So this is given by f of 2 plus n minus 1 into h, and this is given by 2 plus n minus 1 into h whole square. Therefore, integral of x square into dx from 2 to 3 is given by b minus a, that is 3 minus 2, which is 1, into limit as n approaches to infinity 1 upon n. Then we have f of a, that is f of 2, which is 2 square, plus f of a plus h, that is 2 plus h whole square. Then we have f of a plus 2h, that is 2 plus 2h, this is 2 plus 2h whole square, plus so on up to f of a plus n minus 1 into h, that is 2 plus n minus 1 into h whole square. This is further equal to limit as n tends to infinity 1 upon n, 2 square plus here we get 2 square plus 4h plus h square. This we get on expanding this bracket. Now let us expand the next bracket. This gives 2 square plus 8h plus 2h whole square plus so on up to, now expanding the last bracket, we have 2 square plus 4 into n minus 1 into h plus n minus 1 into h whole square. So this is equal to limit as n approaches to infinity of 1 upon n. Now here as we can see that 2 square will appear n times, so we have n into 2 square plus taking 4h common from these terms we get 4h into 1 plus from here we get 2 plus so on up to, from the last term we get n minus 1 plus then we have h square, 2h whole square, and last term is n minus 1 into h whole square. So taking h square common, we have 1 plus 2 square plus so on up to, last will be n minus 1 whole square. Now h is equal to 1 upon n, so substituting here, this can further be written as limit as n approaches to infinity 1 upon n. We have 2 square into n plus h is 1 upon n. So replacing h by 1 upon n, we have 4 upon n into. Now the sum of first n minus 1 terms is given by n minus 1 into n minus 1 plus 1 divided by 2 plus h square, that is 1 upon n square. Now the sum of the squares of first n minus 1 terms is given by n into n minus 1 into 2n minus 1 upon 6. Since we know that sum of the squares of first n terms, that is 1 square plus 2 square plus 3 square plus so on up to n square is given by n into n plus 1 into 2n plus 1 divided by 6, and here we have n minus 1 in place of n, so we get n into n minus 1 into 2n minus 1. Now this is further equal to limit as n approaches to infinity 1 upon n into, now taking n common, first we have 2 square plus 4 upon n into n minus 1 upon 2 plus 1 upon n square into n minus 1 into 2n minus 1 upon 6, and this is equal to limit as n approaches to infinity 1 upon n into n cancels out. Inside we have 4 plus 4 upon 2 is 2, and inside we have 1 minus 1 upon n plus 1 upon 6, taking 1 upon n square inside. So we have n minus 1 upon n, taking 1 n with the first bracket, we have 1 minus 1 upon n into, taking the second n here, we have 2 minus 1 upon n, and this is equal to limit as n approaches to infinity 4 plus limit as n approaches to infinity 2 into 1 minus 1 upon n plus limit as n approaches to infinity 1 upon 6 into 1 minus 1 upon n into 2 minus 1 upon n, and this is equal to 4 plus this term becomes 0, so we have 2 into 1 minus 0, this gives 2, plus from here this term is 0 and this term is 0, so we have 1 upon 6 into 1 minus 0 into 2 minus 0. Since when n approaches to infinity, then 1 upon n is equal to 0, so we have 4 plus 2 plus 1 upon 6 into 2, that is 6 plus 1 upon 3, this gives 18 plus 1 upon 3, and this is equal to 19 upon 3. Therefore, integral of x square into dx from 2 to 3 is equal to 19 upon 3. This completes the solution.